guys, and welcome back to today's video.
Fresh haircut?
Yeah, before break.
Did you cook the turkey or deep fry it?
I did not. We hosted our Thanksgiving, but my mother-in-law and father-in-law brought the turkey.
Oh.
Yeah.
Good?
That's pretty good.
Oh, pretty. That's not a...
I'm a little jealous. I think like some families, they go like all out, like they deep fry it or they smoke it or inject it with different flavors. I'd like a little, I'm not a huge turkey fan, so I'd like to have something a little different, you know?
Have you ever had a deep fried turkey?
I have not.
Has anybody ever had a deep fried turkey?
I hear the key is to keep it frozen right until you drop it in.
Oh my gosh. Has anybody had a deep fried turkey?
Brock said he has.
I don't eat, I ask.
Chicken.
What?
Brock, you have. Did you like it?
Have you, Mr. Park?
No.
Have you guys seen the videos of them putting the frozen turkeys in a fryer?
Have you seen people put ice
Like
in
explode.
It'll shoot it out like a missile.
Or like it like foams up kind of. Like it starts like boiling over.
Yeah, it'll be a bad situation.
Yes.
Chemistry.
Bad.
Science.
Weird science. You
Oh
guys, that's a classic movie, Mr. Westfall.
Yeah?
You never saw Weird Science?
How about Mystery Science Theater?
No. Don't. You just Marcoed it out.
I've never seen it.
They make a girl out of a Barbie, you know, through the computer. It's stupid. All right. Good morning, everyone. Hey, a scatter plot, guys, is when you plot data. And sometimes there's a correlation. Sometimes there's not. And we're going to talk about that. All right. Whoa. Is this the first one?
Yeah, look how that's pretty funny. Should be more like weekly homework minutes.
Seconds.
16.
I was going to say hours. Yeah.
Minutes.
Our kids.
Hours. Who does this for hours?
Well, it could be. No, wait. That's probably for good students. That's accurate. That's also
For good students,
12
yeah.
hours?
Then we got some people in here. Some people in here.
16 hours.
Boom. 1.2 GPA.
You know, I had a conversation with Zach, and he's trying to be James Bond with his GPA.
Oh yeah? 007?
007. That's not good, Zach.
Times 1,000.
Oh.
No, that's not possible.
Yeah, I was going to say, that's pretty good. You watch Bond movies at all?
I used to. I haven't seen since the new guy.
You don't like Roger? I like, not Roger Craig. Craig, what's his name?
Roger.
Not Roger Craig. Anyway, the last one's pretty good. He,
Guys?
I won't spoil
Have you heard? I think they're making a new Matrix.
it. They are. It's coming. I think they've already made it. It's coming out Christmas. Looks pretty good.
Yeah, I mean, watch it on December.
Me? I would say my knowledge of different movies is above average. But if you want to talk movie nut job is Mr. Stadoulis. Nut job?
You love that movie?
That's a movie.
Nut jobs? Oh, you know what?
Oh, I remember that now.
Wasn't that animated about
It is.
squirrels? And
Yeah.
Matt, are you okay?
No, I want to go home. Can I just grab
Did you give the goats some? They get some turkey? It's wrong. Aaliyah. All right, this is going nowhere fast, guys. Now talking about a couple things about scatter plots. First of all, you guys are going to have to do some on the notes here. We'll do one together, but you have to do one for homework and interpret them also. Guys, scatter plots are always labeled, okay? Now, obviously, the more you spend on homework a week, what's going to happen to your GPA? It's going to get better, right? It should improve. Okay, the more a student spends on homework. Now, is there a correlation between the two? Do you see it? Is there a correlation? Yeah, there's a pattern, isn't there? Okay, and we'll talk about that here in a second. There is a pattern. Okay, bless you. All right, so do you guys have this one? I don't think we have to. No, this one. Okay, here we go. This is where you have to start writing stuff down. Scatter plot shows the amount X in grams of sugar and the number of calories Y. Okay, now, sometimes you guys will see this in a book, guys. Look at this right here. Just get your, you see how it's kind of a squiggle? It looks like a little heartbeat. Okay, what that means is it didn't go from 0 to 240, kind of skipped up to there. It skipped from 0 to 46, and they started right there. That's what that little squiggle line means. Okay, if you see that, that's what's going on there. All right. How many calories are there in the smoothie? I almost said a smoothie. Okay. In the smoothie that contains 56 grams of sugar. Well, this one we're going to start out with the sugar. 56 grams. How much, guys? About how much? About what? Oh, I went right past it. About 270. Whoops. And you know about 270 calories. Hello. I feel like Matt right now. You know, I'm going to be honest with you. Since we're talking, I feel honest right now. The Browns played Sunday night. We didn't have school Monday, right? I stopped watching at halftime. I didn't even care.
The Browns.
Yeah. They're terrible. They're miserable. Miserable. Their defense played okay. Yeah. Well, I think that's a matter of fact of, yeah, I think Lamar had a bad game. All right. No, that defense played pretty good. All right. I feel better. So let's go the other way. Let's look up at the start with the, it wants to know how many grams of sugar with 320 calories. So we're going to go up here, go across, here's 320 calories. About how many grams of sugar would it be? About 70. Zach, Jonathan, am I interrupting anything?
No.
Oh, okay. Where? They're on strike.
Oh, that's great.
Can we go on strike?
That sounds like an elf, doesn't it?
This is all the way in the
This
back.
feels like I'm at Santa's workshop.
Whoa, don't say that word in front of me.
Oh, Bailey. Bailey, I like your shortness. I do. You and Alexis. All right. And Anthony. Or Vincent, I'm sorry. You have no idea what's going on right now. All right. Now, what tends to happen to the number of calories as the number of sugar increases? What's going to go on? Lucas, what do you think?
Increase.
Yeah. Okay. And that's just common sense, right? So what tends to happen? So as sugar grams increase, I would just put this. So does the calories. Something along those lines. That's just common sense, right? You know, I found something about pumpkin pie. Not a big pumpkin pie fan.
Great.
It's like so much. I love it.
Not.
I hate pumpkin. What's good?
Whoa. Hang on.
Sabrina wants more math.
Sabrina, listen. Talk to Santa. If you heat up pumpkin pie in a microwave just a little bit, get it warm, oh man, and then put a little whipped cream on there. Oh, it's good.
It's just warm.
I know it's good. What do you want your pizza? What, cold or hot? Oh, it's
Chicken
hot.
pizza with Alfredo. So good.
I like cold.
Dude,
These guys. What's the difference? Is this warm?
Nothing.
Is hot chocolate supposed to be hot?
Yes. Look at the name.
Matt, did you sniff some catnip or something?
Don't want to talk. Don't want to talk right now. I want to go to sleep.
Wow.
I'll go way too early this morning. And
Okay, guys, this is what we're talking about. Correlation. Correlation between two sets of data. If it goes uphill, that's a positive correlation. Okay? If it goes downhill, it's a negative correlation. You kind of see it they group up and they almost form a line. And then sometimes there's no correlation. Okay, which would be no pattern. All right? You know, what could be something that would be a positive correlation? Let's write this in our notes. How about AC units sold? What do you think would be? Why would the AC units sell more? What would go up also? Temperature. Good. Temperature. As the temperature goes up, so would the AC unit sell. What? Miles per hour, what? Could. As your miles per hour increases, what? What do you want to say? Okay. Okay. But is it miles per hour measure rate of speed? Oh, I got you. Distance traveled. We could put that. Yeah, that'd be good. This could be distance traveled, and this could be speed. Yeah, good. Now, how about this right here? How about as let's do temperature increasing right here. What happens as temperature increases? What are some things that could happen? No, it would have to go down. What could go down as temperature increases?
Coats sold.
Yeah, very good. How about coat sales? Okay, coat sales. That would go down. Coat sales would go down as temperature increases. Okay, and this one here, you could do, as the temperature increases here, you could get, maybe number of people at the pool or at the beach would increase too. Now, how about this one right here? Let's do. Okay, your shoe size and your GPA. So, obviously there's no correlation there. You couldn't say, oh, if you have a size 10 foot, you're going to have a correlation or a GPA over 3 point. No, there's no correlation between shoe size and GPA. So there's our three types of correlation: positive, negative, or no correlation. Yes, yes? Here we go. Yeah, and here's one right here. Now, is there correlation here? Corbin, focus in, brother. Is there correlation there? Mary, what do you think? Well, here's the three types of correlation. Kind of go, or no. And does that look like correlation? I would say definitely yes. What kind of correlation here, guys? Positive. positive correlation. Now, that would make sense, right? The faster you're going, it's going to take you longer to stop. And I don't think it's going to, that would, obviously in a car, on a motorcycle. Okay, Matthew running. All right, Mike. Lee, you okay?
Just wondering what resolation is.
Resolation?
What?
Resolation.
Where's Russellation?
That doesn't even
Positive
make
resolation. That definitely looks like
Yeah,
an R.
obviously
It
tell
definitely
us
looks
to
like a U, and it's definitely an S and S and E.
She's not that smart.
What?
You definitely look confused.
You definitely can't see.
Yeah, look at the board. Look at the
I'm looking.
Correlation.
CORRELATI.
That's an O.
Those are.
What do you?
All right.
Oh, yeah.
What if you get a W? Where, who said this?
You said Russell.
Yeah. Russell.
Oh, look at that.
Russell spelled with a W.
It is.
Guys, here we go. Negative correlation.
Wait, one second.
Let's just move on.
Okay, this would be an average daily temperature. You know, you guys see this? Maybe winter coats, sometimes spring coats, but I'm assuming it's coats, period. Okay, this is a negative correlation. Negative correlation. Okay, just stop. Pretty common sense here with the correlation. All right, this is kind of what we're going to spend a lot of time on here. Lines of best fit. I think it's on the back. First of all, to make a line of best fit, sometimes it's called a trend line. There has to be a positive or a negative correlation, or you can't make a line of best fit. Okay? And this is kind of what it's saying right here. Decide whether the data can be modeled by a line. Let's go back to like right here, this stuff right here. You guys kind of see this here. We could draw a line, and when you draw a line of best fit, it doesn't have to, it can't hit all the line or all the points, can it? It wants to, you want to try to draw it where it's going through the majority of them, where you have about the same amount above as below. It doesn't have to be exact, but like this would not be a good line of best fit for that data, right? It would have to be something along, something like this, okay? Now, you can see here where there's no correlation. Could you draw a line of best fit through there? Obviously not, okay? And that's kind of what we're talking about there, okay? Draw a line that appears to fit closely to the data. There should be as many points above as below. Okay, we're going to do this. This is something new. Whoa, forgot I had the line. This is something new. This is something we did all last unit, right? We've been writing equations using 2 points. So that's not new for us. So we're just going to kind of take the next step with this. All right, here we go. What is this showing here? Shows number of years since what? When did they start doing this? What year? 2010, right? So this is 2010 right here. This is year 0. That's, okay, you guys have that there? That's the year 2010. All right. Now, so here's what we're going to do. First thing we need to do, we need the label, right? So this is year. Oh, come on. This is year down here. Okay. And this is going to be number of subscribers. So I think we're talking about a magazine. Now, it'd be good you put this in, label the units because it's in millions. In millions here. Now, is it okay if we go, what do you want to go the year by? What units down here? You just go by what? Just go by 1. Okay, label that in there. What's wrong with West one?
Huh?
What's wrong?
Something next period. I messed something up.
And you're welcome to jump in anytime you want to.
Next slide. Yep, there's this slide or next slide.
This is it.
Can we do that?
I mean, I'll get started here, and then you can.
Yeah, this slide.
Okay, now when we go up the y-axis, what do you want to go up by? Because we got to get all the way up to 89, figure 90. So what do you want to go each line? What do you guys think? 10? No, 5? I'd say 10. Right? I'd say 10. So go ahead and label your, go up by 10 here. 50, 60, 70, 80, 90. And that's all, bless you. That's all we have to go up to.
90.
I think when you do the line the best fit. Intercept with that, it's like 6. If they can into a place that didn't match up to 0 or 9, but that's going to happen sometimes.
Right. Because
We're
we
going past that.
I got that on.
Yeah.
You guys all right with graphing these? 09, 121, 226, 333, 443.
Did you see these 2 tests here? Put them right here.
All right, thanks. 5. Did you enter it?
I think I did.
671,
Let me make sure.
776. 889. You guys get something like that? Positive correlation, negative correlation, no correlation. Everybody agree positive? What's another name for, like, when they say positive correlation, if we were to match a line through this, that line would have a positive slope, right? Positive slope. So let's read the directions again. We graph the scatter plot. This is not a line yet, by the way. We just call this a scatter plot. All right. Write an equation that models the total number of subscribers as a function of the number of years. So, and then lastly, interpret the slope and y-intercept. Do you guys see a line going? Let's kind of picture a line. Now, what were the rules? Has to have the same number above as below. Would that be a good line? The one I just drew. Do you agree it needs some adjustments? Do you agree most of the points are right now below it? Yes? What about now? I got 1, 2, 3, 4 on it. 1, 2 above, 2-ish below. That's not bad. Would you agree? That's not bad. Do you see what you're going after when you sketch a line? You're probably going to need a ruler or some sort of straight edge. If you don't have a ruler, you can use like the edge of a notebook, kind of fold it over and use that as a straight edge if you need to, if it helps you. Now, what we're going to do now, what do you need to write the equation of a line? We have a couple options. We have y-intercept or slope-intercept. we have slope intercept form, which is y equals mx plus b, and we have point slope form, which is y minus y1 equals m times x minus x1. We need to find the slope. So we're going to be doing the slope formula. Don't confuse it. The slope formula is just finding the m.
Yeah, they're in there.
Okay. That's just to find the m, right? So let's pick 2 points on this scatter plot. You said he picked 226?
226 and 76. That's the one with the line he drew.
Okay. I'm going to pick mine if I think it's right. I might actually pick. I want to show you what happens if you don't do that. So here's 2 pieces of advice I would give you when you're picking 2 points. If you pick 2 points that are close to each other, okay, that line could be off quite a bit. If you can find this line goes through 2 points that are kind of far away from each other, that might be better. So let's pick. I'm not going to use the 0, 9 one, and I'll tell you why later. Let's pick this point as one of them, and this point as another one. All right. So we're going to pick the point 226. Yeah. 226. And what's that? 889. So we sketched it. We drew a line that looked like it fit pretty well. And now we're going to write the equation. Then we're going to interpret. So let's find this slope between the 2 points we picked. Well, slope formula, we do 89 minus 26. You'll need a calculator probably. 89 minus 26 over 8 minus 2. What's 89 minus 26? You could probably do that in your head. 63. Over 6. Did you guys write it as a decimal or are you trying to keep it with fractions?
It depends out to decimal. That's the way it just worked out. But I think that did not. That's.
Did you get 10.5?
We got. Oh, sorry.
I used a different point. So
Yeah.
10.5? 10.5 is our slope. Now I'm going to use point slope form. So I have 10.5. All right. Now what point do we want to use? Well, I would pick the one that it went through the best. Which of those 2 points did it go through the best? I think 226. Do you agree with that? 226? So we're going to pick 226 because what do you need to write the equation of a line? A slope and only one point, correct? Point and slope. Well, we have the slope. Let's use 226. So y minus 26 equals 10.5 times x minus 2. There is our line. All right, let's go back to the directions, make sure we answer it all. All right, write an equation that models the total number of subscribers. There we go. Interpret the slope and the y-intercept. Well, tell me if this makes sense to you. 0, 9. 0, 9 is a point on the y-axis. True or false? True. Is 0, 9 the y-intercept of the line we drew?
Yes.
Yes, no, or maybe? Maybe. Do you agree our line didn't have to go through 0, 9? What if the line of best fit didn't go through the point that's on the y-axis? Then do you agree it would not be the same y-intercept? Let me say it again. What if the line of best fit didn't hit that point on the y-axis at all? Then that point would not be the y-intercept of our line. Do you agree? Make sense? So we have to actually find the y-intercept based on the line that is the best fit, not on the point they gave us, 0, 9. We don't know that that's the y-intercept. Okay? So how do we do that? Well, this is okay. This answer right here is okay if all they ask us for is the line of best fit. But if they want us to find the slope, we have the slope. If they want us to find the y-intercept, we actually have to put it in y equals mx plus b form. So let's do that. Y minus 26 equals 10.5x minus double 10.5 is 21. Add 26 to get y by itself. So y equals 10.5x. What's negative 21 plus 6? 5. Would you look at that? What is our y-intercept? 5. But the scatter plot touched the y-axis at 0, 9. Do you see how our line goes through below that? Right? So now they asked us to interpret the slope and the y-intercept. Bless you. What does the slope of 10.5 mean? I'll give you a hint. If you can steal the units, you'll have your meaning. So isn't slope rise over run? Change in y over change in x. Steal the units. What are the change in y units measured in? Subscribers. Per
Year.
See how it's y over change in y over change in x? Subscribers per year. Okay, so what does 10.5 mean? 10.5 million subscribers per year. That's the amount of it's increasing by. It's increasing about 10.5 million subscribers per year. Okay, this might be talking about my YouTube channel. Was this my YouTube channel?
Yeah.
It's about average. 10.5 million. Please subscribe if you like this video. Hit the bell if you want to receive more videos like this, which tomorrow you're going to receive it anyway. So
Daily content.
you can support me on Patreon. What about the y-intercept? The y-intercept is 0,5. So to start out in 2010, that was the starting year. I think 2010?
Yes.
2010, there were 5 million subscribers. If we use this line of best fit. Now, what were the actual? Isn't that green dot the actual data though? So our line predicts that it had 5 million subscribers to start. But what was the actual? 9 million. We're off by a lot at that point. But what if we want to ask the question, how many subscribers will there be in year 10? What if you want to find out how much your channel's growing? Do we have a data point for 10? Do we have a data point for 10? No. Could we find it though?
Yes.
Plug in 10 for x. Let's figure it out real quick. What's 10 times 10.5? 105 plus 5. 110 million subscribers in 2020. That would be 10 years after 2010, right? Does that make sense? That's how you, by the way, guys, listen, this is actually used. Lines of best fit and curves of best fit. This is used in real life all the time. Oh, you had a knee surgery. You were able to bend your knee on the first day after your surgery. You're able to bend your knee at this angle. A week later, you're able to bend it this much more. Let's predict you're going to be able to have full range of motion by, you see what I'm talking about? You see how you can use data points to predict what's going to happen? They use it all the time. Oh, there's this many cases per day in the pandemic. Next week, there's this many. We're we're predicting there's going to be this many after 2 more weeks. Used all the time to predict. Stock market, ups and downs. Good stuff. Would you guys subscribe to my YouTube channel if you?
I like
It's good content. Huh?
I like Jurassic.
Thank you. Appreciate it.
1 million.
Mr. Parker, did I ever tell you about the time I actually accidentally got monetized on YouTube and made $250?
Oh.
Never told you that? Did you guys ever hear that story?
No.
So way back when YouTube started, here, write down the homework. I'll tell you this while the homework is going. While that's up.